This is Yvonne Fish, and in this video we're going to look at data sampling and variation in data and sampling. This is from the OpenStax book. Just a reminder that you should read through your book, at least skim over it and preview some things, get the vocabulary. You don't have to do the problems and things unless I do them in the videos, but mostly you're going to be working from the notes. Just want to remind you of that. Some students prefer to read the book afterward, but the videos may make more sense if you do it ahead. So we're looking at the notes that you can find in your Canvas assignment. This is 1.2. Last video, we talked a bit about the different kinds of data in quantitative versus qualitative. And just some examples to review is qualitative, or categorical it's also known as. It's like hair color, blood type, things that you're describing in words. You really wouldn't make sense to measure it, take an average or something like that and have other mathematical analysis. Quantitative data are numbers, counting, measuring. Just be careful too, though, because sometimes just because something has numbers doesn't mean it's quantitative. So for instance, we talked about zip codes last one. I think jersey numbers for sports, things like that would be qualitative, not quantitative. So just use the context given. Quantitative would have either discrete or continuous variables. Discrete are things you can count. So think of just counting numbers, natural numbers. Continuous variables, they're infinite but not countable number of possibilities. So typically variables that are like measurements. So the weight of something. Here's some examples that we'll look at to differentiate the two. Example 1.6, using the last example, classify each of the following quantitative variables considered in the study as discrete or continuous. So you could just reference like what's up top there in the definition. So number of children, would that be discrete? Are they countable? Kind of one by one, or would there be like fractional parts? Well, I hope one by one would be the answer. So that would be discrete. Household income in the previous year. How'd you think about that one? And daily intake of whole grains measured in grams per day. Think about that one. And go ahead and write your answers down, and then I'll fill it in as well. So pause the video and do that. Okay, so here's the answers to the rest of them. So household income would be continuous, and intake of grams is continuous also. The next definition we're going to look at is the list of observations a variable assumes is called data. Qualitative data are observations corresponding to a qualitative variable. Quantitative data are observations corresponding to a quantitative variable. We talked above about discrete data, and they correspond to discrete variables. Continuous data are observations corresponding to continuous variables. Example 1.7. You go to the supermarket and purchase 3 cans of soup, 19 ounces tomato bisque, 14.1 ounces lentil, and 19 ounces Italian wedding, 2 packages of nuts, walnuts, and peanuts, 4 different kinds of vegetables, broccoli, cauliflower, spinach, and carrots, and 2 desserts, 16 ounces pistachio ice cream, and 32 ounces chocolate chip cookies. Name data sets that are quantitative discrete, quantitative continuous, and qualitative. So quantitative discrete, I'll name a couple. So the number of cans of soup for instance. So see if you can think of another one. Continuous would be the number of ounces in the cans. So see if you can jot down what else you think. Categorical might be the name of the soup. So jot down all the things you think of. Okay, so hopefully you've paused the video and given yourself time. And now I'll reveal the full answer. So we have quantitative, we had discrete was the number of cans of soup, kinds of vegetables, desserts. Quantitative, continuous, number of ounces in cans and desserts. Categorical, names of soups, nuts, vegetables, and desserts. Okay, now for the next part, we're going to look on the next page here. Qualitative data discussion. Tables are a good way of organizing and displaying data. They can be even more helpful in understanding the data. So two graphs that are used to display qualitative data are pie charts and bar charts. So it really just depends on what you're doing and which kind of graph. We'll go into more detail in that later in the course, and we'll be using technology to make these. But you can eyeball things from the tables fairly well, but a graph is even better. So just here's a brief table just to show you numbers versus percent. So percents are relative frequencies, and those are usually more helpful because you don't have to figure out, oh, what's the total. I mean, you might have a small amount out of a small amount or a small amount out of a large amount, and it makes a big difference. So number, we'll talk about frequency, and percent, we'll talk about relative frequency later on when we're looking at things. Pie charts are kind of nice. They give you the wedges and you can see the proportional size. So if we take that info there and put it into the pie chart, it's a lot easier to tell at a glance and compare the two colleges. Bar graphs help you see with the relative size as well with categorical data. Here's an example. And the comparison side by side. Now we'll look at sampling. We'll learn how to make those types of graphs later on shortly and using technology, but we just want to talk about the different kinds of sampling, because really your study or whatever you're looking at in your graphs and your data are going to be really dependent on how good your sampling techniques are. I'm going to do the sampling in a separate video, even though it's in the same section. It's rather lengthy on its own, so I'm going to keep these videos short so you can identify them and go back to them easily for the topics that you're using and referring back to. So we'll wrap this one up and check out the next video in the playlist for sampling.